We saw in the previous video that we could use start buttons to remotely start our motor in either the forward or reverse directions. But we discovered a significant problem. As soon as we let go of the start button, the motor stopped. In most situations, this is far from ideal. Therefore, we need a way to keep the motor running once the start button is pressed. In other words, we need a way to retain the action of the start button. Let's join Thandi Maseku from CTC as she explains and demonstrates how this is done.
Right. We are back, and now what we're going to do is put in what we call retaining contacts. Now, for retaining contacts, I'm going to be using the normally open auxiliaries on each contactor. So to retain the forward contact, I'm going to use a normally open of the forward contactor. To retain the reverse contact, I'm going to use the normally open of the reverse contactor. Now, to just give you a brief explanation what that is, once the contactor energizes, we want to keep it in. But currently, there is nothing that is forcing the contactor to remain energized or coil to remain energized because of the fact that we are only energizing it using the start button, and there's nothing that is forcing it down. So what the retainer does is it is a normally open of the very contact that is now currently open, but when the contact energizes, it's gonna close and allow a flow of current between the 2 points. And when it does that, it's gonna be bypassing basically the start buttons of both the forward and the reverse, allowing power to stay until it is given a different command. So what we'll be doing is I'll be running a cable from the one end of the normally open, run it all the way to the number 3 of each, and then out of the number 4 into the secondary side of the contact. So I'm gonna start wiring those in, and as a habit, I try to start from one side all the time. So I'm gonna start with the reverse contactor. It's the one closest to me, and I'm starting on side number 3. Because this side is regarded as my incoming side, I am going to be putting this cable into the top side of my normally open. That's done. And then the second one, I'm going to be going on the output of my start button. And with this one, I will be going into the other side of my reverse normally open. So the reverse is done. I'm gonna do the same with the forward. Again, I'm gonna be going onto the supply side of my normally open. Remember, auxiliaries don't really have a direction. but it's always a good practice to try and keep your sequencing the same. It eliminates problems and challenges. And this is our last bit of the connection. So what we have now, we have wires that are supplying from the start button, but they're going to be inactive currently. And as soon as we close the start button and the contactor energizes, we're only going to be enabling power to the auxiliaries at that point in time. Now what should happen is I should be able to press the start button of each direction and let go, and the motor must continue running. So with power connected, we're going to start the forward direction. As you can see, I've let go of the start button. The motor continues running. The coil and the contactor is energized. But what is important, my retainer, it's doing its work, because now what is happening with the flow of electricity is I'm coming in and going out, keeping the contactor energized at all times. So the same will happen with my reverse.
Let's pause there and recap what we know. We have wired in a normally open auxiliary contact in parallel with the start buttons. When we press the start button, we energize the coil and close this auxiliary contact. Current now flows through the start button and this contact. But when we release the start button, because this contact is closed, power continues to flow through it, keeping the coil energized, keeping this contact closed and the motor running. Let's return to Thandi as she describes another problem we have.
But now I've got a problem because I don't know how to stop this motor. The only way I've got to take power away. So I'm going to stop so that we are able to see the same effect on the reverse. And I plug power back in. My motor stops, it doesn't run, because neither of the two is engaged, because no command has been given to it. So now I'm going to give the reverse command using the reverse start button, and it should continue running. I've pressed in the start once and I've let go. The coil is engaged and the contactor is energized. My motor is running. And yes, I have a problem. We need to find a way, now that we have the motor working using the start buttons, to be able to stop the motor, so that if something goes wrong, we're able to make sure that we make use of these red buttons over here. And now we're going to bring in the concept of the stop buttons in relation to the start button as auxiliaries. So I'm going to use the stop, or to stop the motor, I'm going to take power away again, and my motor stops. Now, the one thing that you need to take note is the fact that if I put the power back on now, nothing happens, because control remains with the start buttons. So unlike in the first video when I put the power directly to the motor, as soon as the supply is connected, the motor will run. Now we've got control using the start buttons.
So, we have solved our original problem of keeping the motor running. But now, our next problem is that we have no way of easily stopping the motor. other than disconnecting the whole circuit from power. Let's see Thandi explain how to wire the stop buttons into our control circuit.
What we're gonna then do is include the emergency stop and the 2 stop buttons. In order for us to do that, I have to reroute the supply so that I come into the emergency stop. So I will be explaining what I'm doing as I continue. So this was our supply cable. So I'm just moving the supply cable into the normally closed, which is our emergency stop. Now with the supply removed, I am gonna move my bridge piece from the normally closed to put it between the 2 normally, from the normally opens to put it between the 2 normally closed. And then I'm gonna then come out of the emergency stop to bring the supply into the first one. So in order for us not to be confused, I am now gonna put in the bridge piece between the normally close of the reverse and the normally close of the forward, which will be giving supply to my circuit, to my start circuit, in order for us not to get lost. In order to complete the supply, remember I came in with my live on my emergency stop. So I'm gonna go out with the supply live. So my supply is now connected. This is my emergency stop, my first normally closed, which is my reverse. Now I need to bring a supply from the reverse stop into the reverse start. And then remember, the next one is the reverse, is the forward stop, which is this one. And I'm gonna be coming out of this one to supply the start button. We've come in with the live. In the emergency, we're going out into the first stop and we're supplying the first start button, and we're going out with the bridge piece into the second normally close, and we're going into the start. Now we're gonna be putting power back. Nothing should happen with the start button without the start button being pressed. So with power just being connected to the supply, my motor should not be in motion and nothing should happen with the contactors. And as you can see, we've plugged our supply in. Nothing is happening with the contactors. Now remember, from the last video, we could get the contactors energized, but I could not stop using the buttons that are provided here. Now what's going to happen is the emergency stop is going to work in both the directions, but each button must stop its respective start. So again, I'm going to start with the reverse. We've got our motor running. Initially, I had to disconnect the cable for the motor to stop. If I push the stop button, the motor must come to a standstill. I'm going to start it again and then use the emergency in the same direction. So I'm starting the motor. My coil and contactor are energized. My emergency stop is stopping this motor in this direction. Now the same should happen when we engage the forward. Now direction has changed. The stop button is stopping the forward contactor, hence bringing the motor to a standstill. And I start it again, and the emergency stop is cutting supply to the circuit. Now, the right thing that should happen is if the forward contactor is energized, I should not by right be able to engage the reverse contactor. But as our wiring stands now, we have got a problem, because I am gonna start the forward. If I push my reverse start in this condition, my coil is gonna engage, and if that happens, it's gonna disable power, because then I'll have both contactors engaged simultaneously.
Oops! Did you see that? As soon as Thandi pressed the reverse start button while the forward contactor was still energized, she tripped all the lights in the workshop. So, we need a way to make sure that accidentally trying to engage one contactor while the other one is energized does not trip all the power. Let's add these new retaining contacts to our control circuit diagram. Remember that the retaining contacts are normally open auxiliary contacts that are wired in parallel with the start buttons. You must be sure to label them as belonging to either the forward or reverse contactor with F or R. Next, we can add in the various stop buttons. Remember that we had an emergency stop button, a forward stop button, and a reverse stop button. All of these are normally closed push button contacts and are wired in series with the start buttons.